Good morning. I'm so happy for participating in Future Talks, and I'm so glad that you joined us all today. I'm Miram El Maula from Middle East region, specifically from Beirut, and I'm so happy to be a part of Future Talk and to be leader for this design session because I'm really passionate about design and no one like our leaders today, the two luminary, will design our session. Mr. Bjarke Ingels will start with us. Please welcome him.
Pleasure.
Okay, so today, we are here today for Answer the Life. What is the answer to the life, to the universe and everything?
Yes.
Yeah. So with a talk entitled The Architect's Guide to the Galaxy, it might just be you, Mr. Bjarke, who will try to answer this question, at least from your architectural perspective.
We already know it's 42.
Yeah, I know that you designed with your groups a new World Trade Towers and Googleplex, the Hyperloop, and you did even a community on Mars. So, and you produced a robust and progressive body of work at such young age that most veteran architects or even contemporaries could only dream of your achievements in 2016. So, and in 2016, Times Magazine named you one of the world's 100 influential people. So, my first questions for you. As you know, I came. Okay, please, if you sit.
No, I think actually I'm going to tell you a story. So maybe you sit, and then we can talk after if we have time.
Yeah, sure.
Yes.
Sure.
Yes, lovely. So thank you. We have a lot to cover in a very short time. My clock is already ticking. This is the Lego house in Denmark that we designed. And we try to design it like a cloud of overlapping rooms, and we try to make it as interactive and inviting as Lego is itself. So you can actually invade a series of interconnected playgrounds on the roofscape. Inside, I think it's probably one of the only museums in the world where you have to touch all the artifacts. And what I like about Lego is that Lego is not a toy. It's a tool that empowers the child to create its own world and then to inhabit that world through play and invite its friends to come and inhabit that world through play. And I think that's exactly what architecture and design should be all about imagining the world we would like to live in and then make it happen. Actually, the Danish word for design is formgivning. It's the same as true in Norwegian, which literally means to give form to something that has not yet been given form, essentially to give form to the future that we want to live in. And I'll give you some examples of how we've been trying to do this for the last 2 decades. Here outside Oslo in Kistefos, we're building a museum that is a bridge that takes you from one side of the river to the other. In Copenhagen, we created the Copenhagen Harbor Bath that extends the life of the city into the water around it. And in New York, along the waterfront of New York, we're creating the Dry Line, which is a park that's going to keep Manhattan dry when the next Hurricane Sandy comes, but also make the waterfront of New York more inviting. We created a court scraper in Manhattan where we sort of create our own little central park at the heart of the city block, an oasis in the middle of the city. We've created the Infinity Loop in Copenhagen that actually invites people to invade the three-dimensional space of the city block. In Amsterdam, we're making a city block that opens up and invites the port of Amsterdam inside so you can actually sail your ship into the courtyard of the building. And finally, out of envy of the Norwegians, we're building a power plant in Copenhagen that is so clean that we could turn the roof into a ski slope and a hiking path. Interesting. There's a ghost. So basically imagine children, so that's the world-changing impact of architecture, is that children born in Copenhagen this year, they won't know of a world where you couldn't ski on the roofs of the power plant. So essentially that's what we've been doing. Like every time you have a chance to make a building or intervene in space, you're making a small part of our planet a little bit more like our dream world. And of course, if you can apply, so in this, like, the world we live in is the planet we inherited plus our imagination. And of course, we can apply our imagination to other planets. And actually, the last 2 years, we've been working with the Dubai Future Foundation to try to imagine human habitation on Mars. And why Mars? You know, it's roughly the same size as the solid moons of Jupiter and Saturn, but where it's you know, our immediate neighbor in the solar system, but you can actually reach it in only 3 months. Every 2 years, you have a corridor to get to Mars in 3 months. If you compare it to 500 years ago, it took 3 months to sail from Spain to Brazil. So in that same amount of time, we can now reach another planet. And by comparison, if we want to go to the moons of Jupiter and Saturn, it's 2 years and 4 years of traveling. So it's quite convenient that it's so close. Also, it's in the temperate zone. It's not like burning hot like Mercury or freezing cold like Neptune. Actually, in the summer at equator on Mars, you have 20 degrees, a bit like Oslo. It gets twice as cold as Norway, but still. Also, it has a quite convenient gravity. It's 0.38 g, which means that a person weighing 100 kilos would go to Mars and only weigh 38 kilos. It's the fastest 3-month diet that exists. By comparison, the same person would weigh 1/4 of a ton on Jupiter. Then it has a very thin atmosphere compared to the crushing density of Jupiter and Saturn, which also means that it has milder winds than, for instance, Earth. And then I think that the two most interesting things is that it has exactly the same 24-hour cycle as Earth, only it's 40 minutes longer. And I think we could all need 40 minutes more every day, so you can get that on Mars. And then it has, just by comparison, Mercury has a 175-day cycle. So when the sun goes down, it takes 88 days before it comes up again. So we're quite lucky with Mars. And then it has the same seasonal tilt, the same angle to the sun as Earth. It doesn't have a magnetic field, which means it has more radiation. So if we sort of compare the real estate of the solar system, Mars is pretty nice. Also, it has twice half the circumference of Earth, but it has the same land area because it has no oceans. The blue planet, the red planet. And then something funny happens at night when the sun goes down. We all know that the sky turns red on Earth. It actually turns blue on Mars, which is something I hope we will all experience in our lifetime. We've been going to Mars steadily since the 60s. So we've looked at the poles expand and contract. We've looked at craters, lava flows, dried out archipelagos, landslides, dust storms. And we've been driving around. We've seen frost in the morning on the fields. We've seen sort of mountainscapes. It's actually quite similar to Atacama Desert in Chile, which is the place on Earth that is most like Mars, even the colors. So there's a lot of good things about Mars. There's a few challenges. There's too much radiation for humans. There's too little pressure, cold temperatures, there's no breathable air, and there's no ready-to-use water. So we have to work a little. Then we actually got very inspired by Roald Amundsen, the Norwegian explorer, who was the first to reach the South Pole. When he started exploring, instead of bringing his European lifestyle to the Arctics and to the Antarctics, he learned from the Inuit. So he actually became an Eskimo in order to be able to reach those cold climates. So in a way, we have to find what would be the way of the Martian. And we've just tried to learn a little bit from places on the planet Earth that are somehow relevant. This is in Tunisia. something that looks like a lifeless desert, but when you zoom in, you actually find that it's a densely inhabited community. By excavating the homes into the ground, they protect themselves from the sun and the extreme temperatures, the thermal mass of the planet shielding them. Another example in Arizona in the canyon lands, when you zoom in, you actually see that there was, under the shelf of the canyons, you have villages protected from the sun. And of course, in Greenland, Kangerlussuaq, in the cold climates, the insulating snow of the igloo or the thermal mass of the earth mounts, the circular geometry providing an optimum surface to volume ratio. So what are we going to do when we go to Mars? Of course, in the beginning we have to bring our habitats, but then we should, as soon as possible, bring the machines to work with local materials to create habitats, and finally we should bring nothing. In a way, we need to be able to create a circular economy, a closed man-made ecosystem. This is what a person needs, 2 liters of water and some calories. The only sustainable way to provide it is with a vegetarian diet. So in a way, we need to merge the ecosystem of plants and the ecosystem of humans into one unified ecosystem. So if we have to create an ecosystem on Mars, what we have is the regolith. It consists of basalt, Martian sands, and meteorites. If we start sorting the regolith, we can get some ice out that we can use to create water. We can get some basalt rocks, some fine sands. With that and the water, we can actually make bricks, we can make concrete, we can make ceramics, so we can start building. We can also sort the sand into silicia, aluminum, and iron oxide, which are the main components of the sand on Mars. So we can start making metals and glass, we can make electronics, we can make photovoltaics, so we can start creating power. With power and water, we can make electrolysis, so we can split the water molecules into oxygen and hydrogen. With the CO2 of the atmosphere of Mars, it's 93% CO2. We can use a Sabatier reactor to create methane, and with the oxygen, we can actually make rocket propellant, so we can fly home to Earth if we have to. We can also, as a byproduct, we get more water and we get carbon monoxide. With the carbon monoxide and the iron ore, we can make steel. With the carbon monoxide and the water, we can make plastics of different kinds, hard plastics, soft plastics. Of course, we're going to recycle everything we do because we need the resources. The transparent plastics can be used to make membranes, to make enclosed environments. And in those enclosed environments, we can start growing plants for cleaning the water, water for recreation, water for aquaponics, for food production, and we can actually sustain life. So using everything that's already available on Mars, we can actually create a man-made ecosystem. We're going to have to be more space efficient than we are on Earth, 3 times as much. And then there's the issue of radiation. There's way too much radiation on Mars. The typical limit for an airline crew is 20 MSV. You get 110 on Mars. But when you look at the typical American, only spends 7.6% of their day outdoor. So we're saying if we only are in full exposure 18% of the day, we can come down 4 hours a day of outside time. We can come down to the limits of a pilot. So it's not undoable, but instead of just having outdoor and indoor like on Earth, we're going to have much more varied gradation. And then finally, just looking at a few ideas for how to create habitats. Inflatable structures are great at containing an atmosphere, but they're not very protected from meteors. 3D printing offers more protection, but it's less airtight. And finally, excavation gives full radiation protection, but it's not very nice to live in a cave. So neither of the 3 ideas really work 100%, but when you combine them, you actually get, you tick all the boxes. So we imagine that you would instantly create an inflatable perimeter so you can work inside a pressurized environment, then excavate to create spaces for maximum protection, and use the excavation to 3D print environments. So then basically, as you spend your day, you can be sometimes more exposed, sometimes less exposed, and actually reach the good levels of radiation. And then basically, based on this idea, we will start expanding human presence on Mars until we have a city. And the goal for the Dubai Future Foundation is to have a city on Mars in 99 years of 1 million people. But of course, even for an architect, waiting 99 years to complete a project is a little long. So we are actually starting already next year in the heart of the Dubai desert, in the middle of a national park, in a landscape that looks quite a lot like Mars, although it's a lot warmer. We're creating the Mars Science Center, which is a combination of exhibitions to promote the interest in outer space habitation, university and research, agriculture, farming, all created inside an environment that reproduces what we believe will be the most likely sort of form of habitat on Mars. So you can really experience how it's going to feel living on Mars. The interesting thing, since a lot of it will be 3D printed, when you 3D print, instead of having the straight angles that govern architecture on Earth or today, it's more effective time-wise and material-wise with rounded corners. So actually the future on Mars could actually look sort of very friendly and organic. Also, you want to have as much shade from the sun rays. Another thing is the best shield against radiation is actually 1 meter of water protects as much as 7 meters of rock because of the hydrogen molecules. So you can imagine a lot of spaces with skylights that are actually pools, which wouldn't make much sense on Earth, but on Mars, this would actually probably be the best way to have full protection and daylight. And then if you go there, you can actually experience all kinds of technologies related to space exploration. You can see the latest technology within effective farming, and also the membrane is going to create it so that it can regulate the amount of light that comes in. So something that can both function as a greenhouse can also function as a lecture hall. So the big question is then, like, does it really make sense to spend all of this energy on going to Mars? And I think one of the things we've found is that the technology that will be necessary in order to be able to sustain human habitation on Mars are quite similar to the technologies that we actually really need on Earth. If you look at the United Nations Sustainable Development Goals, 8 of them address the built environment directly. And you know, on Earth we have 1.4 billion cubic meters of water. There's only 5 million cubic meters of ice water on Mars, 200 times less than on Earth. So we have to be very water efficient to live there. We will have like 1/10 of the area per person to grow plants, which is also a technology that can be moved back to Earth and help with our challenges here. And of course, like the main causes of climate change on Earth is fossil fuels. On Mars, you don't have any fossil fuels, so everything has to be renewable. So in that sense, you can really imagine that as we get better at inhabiting Mars, we can then travel back to Earth with the technologies. Like in a way, maybe the answer to how to be good Earthlings can really be found on Mars. And then finally, there's the change of perspective. This is the photo Earthrise that was taken in orbit around the moon, where you, for the first time as humans, we were capable to see our home from the outside, start understanding that we have a limited amount of space and we have to take care of it. I'm very fascinated by imagining that maybe our children's children will be standing on the surface of the planet they now call home. They'll look up at the sky and they'll see this shiny little blue dot, which is, of course, reminding them of where they came from. It'll remind them of the journey that got them here, and it'll also make them start thinking about where they're going to go next. So I think I managed to do everything in 17 minutes. Maybe just to enjoy the excess, just as a departing gift, we call Mars the red planet. That's because it looks red, because of the primarily iron ore in the sand. But just like Earth, as soon as we start sort of creating liquid water, and as soon as we start sort of growing plants that can actually grow on Mars, those plants are going to sort of put oxygen into the atmosphere, and in just 200 years, this would be what Mars would look like with a biosphere and an atmosphere. So also on that notion, and then suddenly Mars doesn't look so different from the blue planet we know. Thank you.